Question 8 introduces another slight kind of twist on these kind of questions, because on the face of it this is just another cycle based on enthalpies of formation, because those are the data you're given. But there's a twist, which is that it tells you what the answer is for the overall delta H of reaction is minus 64 kilojoules per mole, but part of the data is missing, and that's what you have to fill in. So again, there are probably different ways you can approach this, but here is a suggested way to do it. So the first thing is just set up the cycle in the normal way. Recognise that the numbers you've been given are enthalpy changes of formation. That's always what you look at first, because that tells you what the outline of your cycle is going to be. So if it's formation, it means the data relate to formation from the elements. Okay, remember that's what delta H of formation is. So going up that way, if we form those compounds from the elements, it's minus 219 for the PBO, because there's just 1 mole of that. And then this is the one we don't know. So what we can say is that it's minus 219 plus X, where X we're defining to be the enthalpy change of formation of carbon monoxide. Okay, so we're just going to call it X, and then we're basically going to solve for it in a minute. Now, if we go up this way, lead is still an element, so it hasn't changed in going from elements to lead, so that's why there was no number for that, because we didn't need one. There's been no change. But CO2 is minus 394, and again there's just 1 mole of it, so that goes on to there. Okay, then we do our Hess's law thing and say, right, this is the overall change, and that enthalpy change, minus 64 kilojoules per mole, will be the same if we do it in 2 steps like that. So this plus this adds up to minus 64. So if we look at the first of those, that's the opposite of this one. Okay, because we're going in the wrong direction, so the signs change. So it's plus 219 minus X. Okay, because you're unforming those, not forming them, so the signs change. Second leg is the same, no change in direction, therefore no change in sign, so that's minus 394. So now we can write our usual kind of statement, which is this plus this equals this. So we've got plus 219 minus X minus 394 is equal to minus 64. Okay, and then a little bit of very gentle algebra changes that into plus 219 minus 394 plus 64 is equal to X. And if you just crunch that, you get minus 111 kilojoules per mole. Okay, so that's the answer, because that's what we defined X to be, the enthalpy change of formation of CO. So whenever you get questions like this, where it kind of gives you the answer but one of the bits of data is missing, that's the easiest way to do it, is just substitute it in as X, crunch the numbers in exactly the same way you would if you had them all, get a statement, and then solve for X. Question 9, we have a similar scenario to 8 in the sense that we've got a problem where it gives you the answer but some of the input data are missing. So we're going to take a similar approach. First thing to notice this time is that the data you're given are enthalpy changes of combustion, not formation. This time so it's going to be a different kind of cycle, where what links the two sides are going to be the combustion products, which, because we're talking about organic compounds, hydrocarbon here, and carbon monoxide and hydrogen, when those things burn, we're going to get carbon dioxide and water. Okay, so carbon dioxide from any of the carbon-containing compounds and water. And again, I'm not going to bother balancing it, I'm just going to write it like that. So, again, begin just by constructing the cycle. So, remember, combustion means that you take these compounds and they burn and they turn into the combustion products. So the arrows go that way. Okay, so when you burn 1 mole of methane, it's minus 808. Water, of course, is one of the combustion products, so it's not changing and going from there to there, so there's nothing to worry about there, no contribution from that. Carbon monoxide is minus 283, so when you burn that and make CO2, that's minus 283. Now hydrogen is the one we don't have any data for, so again we're going to bring X in. So let's do our definition, right? It's a good idea to write down the definition so that you and anybody looking at your working can understand clearly what X means when you introduce it. So if we define X to mean delta H of combustion of hydrogen, because that's what the question asks us to find. So we'll define that to be X, and you can see that going from here to here, we're burning hydrogen to convert water, but we're burning 3 moles of hydrogen. So let's say plus 3x. You could just call it x and divide by 3 at the end, but I think it's easier and safer like this to define x to be the thing you're trying to find, and then realise, yeah, but that means for burning 1 mole of hydrogen, but you're burning 3, so it's plus 3x going down there. Okay, so then we do Hess's law and say, right, this number across the top is equal to the sum of the enthalpy changes for going down there and then back up here. So the first leg is the same as that. The arrow's going the same way, so the number is the same, minus 808. But the second leg coming up here is the opposite of that one. So if the opposite direction means the signs change. So it's plus 283 minus 3x. Okay, because we're, if you like, unburning the CO2 and water to make those products, so we change the sign of the delta H. So then we can make our enthalpy statement, which is that minus 808 plus 283 minus 3x is equal to plus 333. Okay, so that's saying that that leg plus that leg equals the overall change. So minus 808 plus 283 minus 3x is equal to plus 333. Okay, so a little bit of rearranging here will then give us minus 808 plus 283 minus 333 is equal to 3x. Okay, so that's just subtracting 333 from each side to bring that over to there, and then adding 3x to each side to bring that over to there. So we get that equation, which gives us that minus 858 is equal to 3x, and therefore dividing by 3 we get minus 286 is equal to x. Okay, so that gives us our answer then, that the delta H of combustion of hydrogen is minus 286 kilojoules per mole. Okay, so the best way with these questions is write it all out explicitly in a cycle. Don't try and cut corners. Apart from anything else, if you mess up the numbers, the cycle is the best way to get some of the marks, to make it clear that your thinking was fine and you just messed the numbers up. But you're also less likely to get it wrong if it's there visually, because you can sort of see the way the sign should change and you know, see if you've forgotten to do one or whatever. So that's your answer for 9. Question 10 then, these are the data. It gives us delta H for this reaction. So ethene plus steam, which is a reaction you know from organic chemistry, has a delta H of plus 144 kilojoules per mole, so it's an endothermic reaction. And it gives us the enthalpy changes of formation of ethene and steam from their elements. And this is the one we don't know, and we've got to find the enthalpy change of formation of ethanol. So again, start by constructing the cycle. Recognise that these data that you're playing with are formation data, so that means that the cycle will have elements forming the link between the two sides. And formation of the things on the left from the elements means you have an arrow going that way. So forming the compounds from the elements, so the arrow goes that way, and it's plus 52 for the ethene, minus 242 for the steam gives us minus 190 is the total going that way. Going this way, to take that same set of elements to make ethanol, that's the one we don't know, so we're going to call that X. Okay, so the change there is X, and again it's a good idea to define that, to say that X is equal to the delta H of formation of ethanol, just so that everybody, including yourself, is clear what you mean when you suddenly introduce X like that. Okay, then you have the Hess's law statement. So this change is equal to that plus that. Hopefully you're beginning to get confident with this now, that we're just making an indirect route that corresponds to that one, and then we're just equating the numbers. So we get that plus 144, which is the overall answer, is equal to this plus this. We worked out it was minus 190 forming those compounds are going up that way, so we're doing the opposite. We're unforming them, so that's going to be plus 190 coming down here. So plus 144 is equal to plus 190, and then going up there, that's the same as this, which is X, because the arrow's going the same way. So it's plus 190 plus X. So we get plus 144 minus 190, which is minus 46, is equal to X. Okay, so that's our answer. So therefore, delta FH, enthalpy change of formation of ethanol, is minus 46 kilojoules per mole.